Hello, friends. We are on our AI A to Z journey, and I'm Dr. Sonali Tamhankar. With ChatGPT's record breaking rise and massive influence today, we have to talk about GPT, right? Let's do it. AI for the Intrepid, G is for GPT, Generative Pretrained Transformer. We have talked about embeddings and foundation models. Word embeddings convert words into numbers, or more precisely, vectors, so computers can do math with them. We have only discussed static embeddings so far, one word, one vector. But human language is tricky. For example, the word bark can mean dog bark or tree bark. Which one do we mean? How does a computer know? So moving from E to F in foundation models, we discussed self-supervision and how models learn by predicting the next token. Early language models used technologies like RNNs or recurrent neural networks. However, these had some shortcomings. They processed tokens sequentially, so they were hard to parallelize during training and couldn't fully benefit from hardware advances like GPUs that made computing much faster. Now, remember, language models are dealing with massive amounts of data, so this is critical. Also, RNNs had a bit of a memory problem, like someone gradually forgetting what was said at the beginning of a sentence by the time they reached the end of it. So, the dramatically titled paper, Attention is All You Need, by authors from Google, introduced the concepts of self attention and transformers by considering the whole sentence at once. It allowed for better parallelism and better context retention. This was the beginning of a whole new era in AI. This paper is one of the most cited papers in modern computer science with over 200,000 citations. See, even Calvin knew the importance of attention. So let's consider the sentence, the dog's bark was loud, and look specifically at the word bark. The attention algorithm looks at which words in the sentence are most relevant to it. Multiple attention heads are trained. One may figure out that it's the dog who is barking, and another may pay more attention to loud. The attention heads run in parallel, and self attention looks at the whole sentence at once, which makes training much more efficient, especially on state of the art hardware, because it can be parallelized. Context is retained across the whole sentence. If a word at the beginning is relevant to another word towards the end of the sentence, that link is given high attention weight. On the other hand, the links go from all words to all words. So this is quadratic complexity. So it's computationally expensive. Due to compute and memory constraints, practical implementations typically use fixed context windows. You may have heard of it. Positional embeddings keep track of the position of the word in this context window, and the paper shows how to use self-attention to build contextual embeddings by taking surrounding words into account. Now let's consider a second sentence. The tree bark was rough. To compute the transformed contextual embeddings, we take the original embedding, shown in color blue here for the word bark, and then mix in just a little bit of the embedding vectors of the nearby tokens, weighted by these attention weights. So in the first sentence, if we denote the embedding vector for the word dog by yellow, a little bit of this yellow gets added to the original blue, and the contextual embedding vector for bark gets tainted this greenish blue shade. In the other sentence, the word bark appears with the word tree. So it gets a little bit of that embedding vector shown in red, and then you get this purplish shade of blue. So we are literally capturing shades of meaning here. Isn't this brilliant and beautiful, almost poetic? So we use this transformed understanding of the input to predict the output, which interestingly happens still one token at a time. So these are subtle concepts. That's why I've titled this episode AI for the Intrepid. We are wading into this territory with the fearless curiosity of Calvin and Hobbes. We haven't even touched on vanishing gradients and query key value computations or the architecture of encoders and decoders. If you want to dive into these technical topics, I include some resources below. Okay, so we have talked about the attention paper, its contributions, and the contextual embedding vectors. A couple more points. In a work that followed the attention paper, OpenAI authors introduced the phrase GPT for generative pre-trained transformer. To be clear, almost all of today's models like Gemini or DeepSeek are generative because they generate output like recipes and poems. They are pre-trained on mountains of data and they are based on the same transformer architecture. So functionally, they are all GPTs, but as a phrase, GPT might specifically mean the models built by OpenAI like GPT-5 or ChatGPT. Also, as groundbreaking as the transformer architecture is, research continues, as it should, into wholly different approaches for representation learning, like the VLJPA paper that just came out in December 2025. Okay, so while GPT is famous for text, this architecture is highly adaptable for all kinds of sequential data. For example, Delphi 2M is a healthcare specific model. It's a modified GPT model trained on data from 400,000 individuals. Language models train on words or parts of words as tokens. Delphi uses over 1,000 distinct tokens based primarily on ICD codes and also some lifestyle factors like smoking status. So we talked about ICD codes in EAs for embeddings. They carefully label different diseases like diabetes or hypertension. So Delphi kind of reads people's health lives and trains on this data. Then we can give it an individual's health events to date and ask it to predict what comes next. It can predict the risk of more than 1,000 diseases based on an individual's past disease history. Okay, in fact, we can even give it just birth and sex information just to get it started and ask it to predict everything that comes next. So this generates fully synthetic data. We have H is for hallucinations next tomorrow. And an innovative use of a model like Delphi is to help anchor large language models so they understand health trajectories better, which can reduce hallucinations. Okay, so our 3 takeaways for today. Attention paper is groundbreaking with over 200,000 citations. Transformers introduced better parallelism and better context handling. And GPT applications extend beyond LLMs, like in healthcare. That's it for today. Tomorrow, we'll talk about AI hallucinations, some of which are highly entertaining. See you then. Bye and have a nice day.